My name is Barry Schnur. I'm the CEO of David Schnur Associates. Noel Taylor has been working with entrepreneurs, designers, and established design teams in the medical device industry for over 25 years. Well, thanks for joining us today.
Thank you, Barry. Appreciate being here.
Noel, we've got a great slide up of some representative formed tubing products. Forinno obviously has promoted quick turn prototyping of complex designs for many years of products that look a lot like this. How are you able to mold complex geometries with a low tooling investment and the short lead times that you talk about? And thanks for being here, of course.
Thank you, Barry. Essentially, we have a heating technology that's a tabletop molding application, and we make all of our tools in-house. So we can actually take a drawing from a customer, a hand sketch or a SolidWorks model, go out to the machine shop, make a tool real quick, get it onto a bench top and run some prototypes. The best thing that we see that helps our customers get to where they need to be is going from that concept to an actual part in their hands. Getting that part in their hands usually sets us up so we can go through a couple iterations to get the part just like they want it to. We can go through these iterational steps usually in a few days. Sometimes it takes a little bit longer if the complex geometry requires us to get a mold made by somebody else, but we have partners that are close by that can get these little inserts for us very quickly.
Great. And yet, I think one of the other keys is that this isn't just a prototyping technology, right? I mean, we've seen this scale into pretty high volumes.
Exactly. We can take the first tool and make the first batch of prototypes, go into clinicals, go into pilot production. Then typically we can scale up. And since we are working with a tabletop platform, we can go from one tool to as many as 20 tools with a couple operators running those. So scale is something that we're fairly comfortable with. And the applications that we choose to work on with the DSA reps and the customers are usually really focused in on our specialty technology of doing the tips, the flares. So we do a little bit of work up front to make sure that what we're going to ramp up in pilot production is something that's actually going to be manufacturable at full scale.
Great. Forinno has been really successful in modifying challenging materials, and I mean there are technical reasons related to those, to the process and the way that you go about doing this. In many cases, engineers have used less than ideal materials due to manufacturing constraints. Can you talk about why and how the Forinno process lends itself so well to modifying materials like PEEK and the fluoropolymers?
Certainly. So things like PEEK are typically really sensitive to heat fluctuations. If you heat it up too quickly, if you cool it down too quickly, it can get brittle. It can change the crystallinity. So we try to give it the lightest touch possible. We also have very selective heat zones. So you might see somebody trying to make a part with an injection molding machine to do a PEEK part, and it'll end up with various different crystallinity because it's going through a fairly hard process to get it into the final shape. We're actually trying to very delicately push or pull the material into the shape that it's going into. And this keeps it from going into any different sort of crystallinity, causing it to have any sort of issues. PTFE and other plastics that are not necessarily known as thermally processable also work well in our processes, so we can get them warm enough to move them around, but we're not actually getting them into any type of melt temp. And this sort of experience with very gently moving around the polymers allows us to do quite a few things that other folks think are not quite achievable.
Yeah, I mean, some of these are thermostats, right? In fact, like a polyimide, which I've seen you modify as well.
Yeah, that's actually something we started doing a couple years ago that I actually really liked, was making shape polyimides that didn't necessarily have to be formed in a specialty shape in the first place. We can take tubular configurations and take a section of that and make it triangular or square, so that you could actually have different profiles along the length of a thermoset, like a piece of polyimide or PTFE, any of those other exotic engineering materials.
That's super interesting. Um, in many, if you think about an inner member, a middle member of a complex delivery system, there are pieces of that that are, okay, sometimes metal, sometimes polymer, some places that it might benefit from incorporating both of those. Can you talk about your experience in blending multiple materials, polymers, metals, thermosets together, and how that sort of works with your process? How would that happen?
Well, it's fairly industry standard to have smooth liners like polyimide liners, PTFE liners on things. Where it gets a little more exotic is doing a joining operation from like a PEEK, for example, to a stainless steel or Inconel hypo tube. We have experience reshaping the end of the polymer tube so that basically becomes a mechanical grip with the metal substrate. We can also incorporate little features that are basically going to make mechanical on a microscopic level interfaces between the two polymers. Once again, we go back to our heating technology and the application of heat to the exact right temperature and the exact right place is what also allows us to put together dissimilar materials like nylons and P-baxes and polyethylenes. Sometimes some pretty complex examples. A lot of times our customers will be trying to find a lubricious property and a flexible property. And a lot of times we'll do the experiments to try to help them find a way to combine materials so that they can get pushability at the same time that they can get good flexibility. And oftentimes those two don't go hand in hand.
So fair to say that sometimes you'd be creating a component, sometimes it would lend itself more to a subassembly, and other times perhaps a completed device like a sheath or an introducer in total.
Yes, we do a fair number of shaft assemblies, dilator and other components where there might be a soft tip and a rigid section. So we take the tipping technology that we really focus in and make it so that it could be applied to a multi-component part for a customer.
Great, thank you. Please do follow up with us on anything specific. Again, you can either get a hold of us through the DSA website and just send us questions with what you need.